Right. Last thing I was discussing was the Z effect and the meaning of Z effect. And as I told you, the Z effect means the effect of the nucleus on the outer molecule. The effect of the nucleus and the outer valence molecules. So this is the valence molecule. Oh, sorry, not molecule, but electron. Valence electron, and what's the effect of the nucleus and this valence electron? Of course, there will be some core electrons inside. The core electrons actually shield the valence electron. Okay, and this is shielding, and this is the atomic number, and that is Z effective, which is the effect of the nucleus on the valence electron. As I told you, the most important thing is I want you to know as you go across the periodic table what's happening to Z effect. It's actually increasing in value. Increasing in value, this means the nucleus is able to attract the valence electrons closer to it, or become closer to the nucleus as you go across the periodic table. As a result, what happened? The size of the atom also is effective, and you can see that as you go across the periodic table for the main group. This is the main group elements. Main group elements. What do you mean by main group? What's the meaning of main group?
The elements group 1 and 2.
S and P group. It's S and P group. If you look at your periodic table, look at the S and P group. All right, and which is 8 elements together. So if you count here, there are 2 for the S, which is this is alkali and alkaline, and this is boron, and then carbon, nitrogen, oxygen, fluorine, and neon. That's the main group, the S and P elements. What happened to the size as you go across the periodic table? What happened to the size?
Decreasing.
Decreasing. What happened to the size if you go up from up to down?
Increasing.
Why? Because you are building new shells. As you go across, you are building new shells, new electrons is coming, and the size become bigger and bigger and bigger. Is this clear?
Doctor?
Yes.
This applies only S and P group.
You'll apply it only at S and P at this time, yes.
Okay.
How do we measure the atomic radius? We measure the atomic radius by taking 2 atoms together like this, and then take the distance from the nucleus to the nucleus. These are the same atoms arranged, atoms, and take the distance from the nucleus to the nucleus. This is, and then of course, if I want the atomic radius, what's the atomic radius?
Half.
S is this distance, which I'm going to call A divided by 2, exactly. Why? Because if this distance from here to here is A, then the atomic radius is A divided by 2. If it's a covalent compound like this one, only 2 atoms, same thing. If we have, for example, oxygen and oxygen, what's the radius? If this again, this is A again, then what's the radius of oxygen atom, let's say, if this is oxygen atom? Yes? Again, A over 2. I hope this is clear. Good. Now, as we said, the reason why the size is getting smaller and smaller and smaller, because mainly it is the Z effective increasing as you go across. Okay, so as you go across, the attraction between the Z effective and the electrons outside are stronger and stronger, and the size become smaller. Good. Now, referring to the properties of periodic table, which element is bigger, P, S, or O? Which is the biggest and which is the smallest?
Smallest is O.
Okay, O is the smallest, and then
S, then B.
Then P, then S.
so O is less what?
Then
O
S.
than S. No, you can't compare things together. O and S are like this. Which one is bigger?
S is bigger.
S is bigger. Now we have P and S in the periodic table. Look at your periodic table. They are
P.
like this. Which one is smaller?
S is smaller.
S is smaller. So which one is the smallest?
Oxygen.
Oxygen.
Then S.
Phosphorus is the biggest.
P is the biggest. All right. Good. And that's the solution. As you can see here, O is above S and S. So actually, this one, P is bigger than S and S is bigger than O. Good. Next.
Doctor,
Yes.
the biggest is hydrogen.
The biggest is hydrogen.
Yes, for all elements. H.
You should tell me which one is the smallest thing in the whole elements.
Hydrogen.
No.
Helium.
Yes. Helium is the smallest ion or atom.
Then hydrogen.
Then hydrogen. These are the top here. This is the second group, but this is hydrogen is also here. And then hydrogen and helium are the only 2 elements in the periodic table. And as you go across from hydrogen to helium, which one is smaller?
Helium.
Helium, yes.
Is this than hydrogen? But hydrogen is smaller than any other elements under it. Okay. Now, next, I want you to write the word ionization energy. Ionization energy. Ionization energy is this reaction. This reaction is delta H for this reaction is called ionization energy. What's the definition of ionization energy? Tell me, what's ionization energy? Look at the chemical reaction. Tell me what's ionization energy.
The energy need to ionize an atom.
To ionize the atom. What do you mean by ionize the atom?
Give an electron.
What?
Give
Remove
an electron.
Move electron. But the element should be in what state?
Gas. Ground.
Gas. As gas, not solid or liquid. It must be in gas. When you take the first electron, you call it first ionization energy. First ionization energy. Clear? All right.
Doctor,
Should be at the natural state, doctor.
What?
The element should be in its natural state.
In gaseous state. It must be gas. Look at here, the word gas and gas. It must be in gaseous state, not solid, not the natural occurring state.
Okay.
doctor.
Just gas, yes.
So if I give an electron to chlor, is it ionization energy or
No, when you give, that's different than from you take. The ionization energy is to take, require to remove an electron from atom in what?
gas?
Gas phase. So read this again. Read this. What's ionization energy? It's the energy required to what? Remove
To remove an electron from an atom in the gas phase.
atom in gas phase. Everything in gas phase. And this is the reaction that represented for sodium. Okay? We know that what's this? This is defective. Right? What happened if you go across the periodic table with the Z defective?
And bigger.
Bigger. And what happened to the size of the atom?
It becomes bigger too.
Size of the atom?
Smaller.
Smaller. We said this already. All right. Now, is it easier to take the electron from here or from here?
From lithium.
Easier or harder?
Easier.
Excellent. It's easier to take the electron from lithium than from fluorine. So, ionization energy. What will happen to the ionization energy if you go across the periodic table from here to here?
Gets stronger.
It come what?
Gets bigger.
Harder.
Bigger.
Right? Increase the numbers. See, as you go across, generally, what happens to the ionization energy? It is what?
Increase.
Increasing. Look at the numbers very well. As you go across, generally speaking, it is increasing. As you go on the other side, what's happening to the ionization energy? As you go from up to down?
Decrease.
Decrease. Can you see this?
Yes.
So it's the opposite with the atomic radius, right, doctor?
Yeah, the down is exactly, everything is opposite to the atomic radius, exactly. Because of that, because the atomic radius, as you go across, the atomic radius becomes smaller. Decrease, while the
Ionization energy.
ionization energy
Increase.
increase because of that. Because this decrease, this means you cannot take the electron away. It becomes harder to take the electron. Is this clear? Okay.
Yes.
Look at the numbers one more time for the first group. Lithium, Be, B, C, NO, F, Ne. Look carefully. It's always decreasing.
No.
Is there exceptions?
Yes.
Yes, between nitrogen and oxygen.
Nitrogen and oxygen, yes. Between nitrogen and oxygen, there is exception. What's the other exception?
Phosphorus and sulfur.
What?
Phosphorus and sulfur.
Phosphorus and sulfur. Oh, no, let's look at the first group only. We're looking at first group only.
Oxygen and fluorine.
Oxygen and fluorine, no. It is increasing.
Be and B.
Yes. That's the other exception. Be and B.
And
Not increasing. And between N and O, it's not increasing. Is this clear?
Yes.
First group. We want to know what's the reason. What's the reason? Can you tell what's the reason? Why do you think it decreased from BE to B?
Maybe there is exception
There is
to
a gap.
the atomic radius.
What's the electronic structure of the B? BE. BE is 4. BE is 4. So what's the electronic structure?
1 is 2.
1 is 2.
2 is 2.
2. Right?
Yes.
How about B, which is 5?
1 is 2, 2 is 2, 2p1.
P1. So try to, since we find that the energy here is less than here, what's the reason? What do you think the reason is?
B is bigger in size.
Because we start a new energy level 2p. Is this clear?
Yes.
That's why the value decreased in this case, but start increasing again. Now, let's look at nitrogen and oxygen. If this is nitrogen, and then this is oxygen, and if you draw the electronic structure for nitrogen, 1 is 2, 2 is 2, 2p3. 1, 2, 3. When you go to oxygen, it is 1 is 2, 2 is 2, 2p what? Hello?
4.
4. So 1, 2, 3, and 4. Again, decrease here. Why do you think it decreased? Give me a good reason. Look at the electronic structure and tell me what's a good reason.
Because it have more electrons than p orbital.
Yes. No, it's only one thing. Look, what's the difference between the p orbital of nitrogen and the p orbital of oxygen? What's the difference?
Nitrogen
Yes.
is stable.
There is no electron.
Oxygen has there.
You know, in oxygen we have 2 electrons together in one of the rooms.
Yes.
While for nitrogen, there is only 1 electron in each room. What's the charge of the electrons? What's the charge of the electron?
-1.
They have one charge, either half or minus half.
No, that's not the charge. That's the spin. The charge is -1. The charge is -1. The spin is minus or plus half. So the charge is always -1. Clear? What happened to the electrons if they are together in the same room? If you have two magnets,
They will cancel each other or
no, not cancel.
repulsion.
Repel each other. So the electrons repel each other. ايش معنى repel؟
يدفعون بعض أو أنهم يتنافرون.
تنافر. Because of this تنافر, because of the repulsion between the two electrons which have the -1 charge, this number became less than. For oxygen, 1314 is less than 1402. Is this clear? And that's why we also see it. We see it here, the numbers, and we see as you go from lithium to nitrogen, to neon, sorry. From lithium to neon, this is the first group. What's happening as you go up from here to here, generally?
2 corners.
Right? Is there exception? This exception
Yes.
and this exception. Clear?
Yes.
Very good. So are the exceptions. Very good. Next. Ionization. We are still in the ionization energy. We call the first, if you have lithium, going to lithium plus electron. What do you call this?
Ionization.
First ionization energy. Okay. You go lithium, everything must be what?
Gas.
Gas. If you have lithium plus gas, goes to lithium what?
Plus.
2
plus electron. We call this second ionization energy. If you go lithium 2 plus gas plus goes to lithium 3 plus gas plus electron, we call this
Third.
ionization energy. Can we have fourth ionization energy?
No.
No.
Why not?
Yes, we can.
Lithium is only
The
3.
table is not
It's only 3 electrons.
The electrons, exact. Only 3 electrons. Okay? Let's still talk about lithium. How many valence electrons do you have in lithium?
What?
Valence.
1.
Electron 1. How many core electrons?
3.
3.
No, core electron.
2.
Core is electrons other than the valence.
2.
2.
Exactly. Is this clear? Okay. What's the meaning of valence?
اللي في آخر مجال.
اللي أي مجال، مو أي مجال معين.
الأخير.
ها؟
الأخير.
It's P orbital. Last is some P orbital. What's the valence of BE? And then BE. Look at your periodic table. Tell me lithium, BE, B, and then after B, carbon, and then nitrogen, oxygen, fluorine,
2.
and neon. In BE, how many valence electrons?
2, 3, 4, and so on.
2, 3, 4, 5, 6, 7, 8.
Okay.
Exactly. What's the core electrons for BE?
2.
2. And then
2.
2 for carbon, for nitrogen,
2.
for oxygen,
2.
for fluorine,
That's it.
for neon. Exactly. I want you to know this. These are called valence means, don't forget this at all, last sp electrons. Last sp, which is in this case 2s2p. And this is the core electrons is 1s. Clear? I hope so. Now, I want you to concentrate. This is the value. This is the value for ionization of all the elements. I wrote you the equation for only lithium, but you can do it for any other things. And lithium will stop at 3 because there will be no more electrons. But BE will stop at 4. And when we go to neon, we'll stop at 8. Yeah.
Why 8?
10. 10. Neon will stop at 10. All right? Okay. Next. I want you to notice here, look at lithium. What was the first ionization energy, the value?
520.
What's the second ionization energy?
7,000.
Okay. Okay. I want you to tell me why you think this big increase.
Because after losing the first one, there are only 2 level S and they are full. So it's harder to.
Exactly. Because you can imagine this is the lithium, this is the 1s, it's very close to it, and the 2s is very far from it. So when you take, this is the valence, this is valence electron, and this is core electron. For lithium, you take the first one from the valence electron. When you want to take the second one, where are you going to take it from?
It's near to the.
From the core electron.
From the core.
Very close to the nucleus, and it will be very difficult. Is this clear? Then let's go to BE. BE. How many valence electrons do you have?
2.
And how many core?
2.
Good. Now, look at the numbers. What happened here? 899. Then, second ionization energy, 1,700. Third ionization energy, 14,000. Okay, tell me why.
Because this core
Because taking the first electron is 899. Which is harder to take, BE or lithium? To take the electron from BE or lithium?
B.
B.
Why?
Because it's on the right.
What?
On the right.
The radius is smaller than the lithium.
Yes, remember, this is what happened. As you go across, what happened?
Decrease in size.
Increase in size and increase in ionization energy. And that's why in this table, as you go from here to here, the first ionization energy only, what happened? What's happening?
Increasing.
Increasing. Is there exception?
Yeah.
No.
Yes.
Yes. Where is it?
BE and B.
NE and A.
Nitrogen and oxygen.
Nitrogen and
Right.
oxygen.
And oxygen, exactly. We talked about this a while ago. Now, let's go across. So this one is higher than this one, okay? And then when you go from the second ionization, it will be 1,700. Third ionization, 14,000. Why is the big increase?
Because it's the approach to the core.
Yeah.
Is we reach the core electrons. Exactly. When are you going to accept the big increase for carbon? Look at the number of valence electrons. How many?
4 to 5.
From 4 to 5. So look at the number for carbon. 1, 2, 3, 4. 1,000, 2,000, 4,000, 6,000, then
37.
37,000. 37,000. Okay, I hope so. Good. When do you expect to see the biggest number for fluorine?
After the 7th.
After 7. Yes. So you should count 1, 2, 3, 4, 5, 6, 7. Okay, still from 1,000 to 70,000. But look, after 7, from 17 to what? 92. And so, from looking at the numbers, you can tell what's the valence of any element. What's the valence of nitrogen? Without looking at the number down there. What's the valence from these numbers of nitrogen? You should look where is the biggest increase, and then count the one before it, and that's the valence. So what's the valence of nitrogen?
5.
2, 3, 4, and 5. Can you tell? I hope this is also clear and obvious.
Why is it so big after the valence levels? Is it because it's near the nucleus?
Exactly.
The core electron.
Electrons are very, very close to the nucleus. This is the nucleus, and the electrons are becoming very, very close. Is this clear?
Yeah.
Would you expect sodium or Mg to have ionization energy higher? Sodium or Mg? First, ionization energy.
Mg.
What is higher?
MG higher.
Mg is higher. Why? Because generally, as you go across, what's happening?
Decreasing in size.
Decrease in size and increase
in size, increasing ionization energy.
Is higher than sodium, or sodium is less than Mg in first ionization energy. How about second ionization energy?
Same.
The sodium is higher.
Sodium is higher than Mg. Excellent. Why?
Because Mg will be higher than
Because
we will reach to the core.
Core electrons, exactly. Mg still valence electron. So the second ionization is higher for sodium than Mg. Very good. Is this clear?
Doctor, how can I know the valence number?
Already do know it from the periodic table. Do you have periodic table?
Yes.
Valence in the periodic table. We already, this is part of the periodic table. We put numbers, I told you, the 1, 2, 3, 4, 5, 6, 7, 8. I can't tell what's the valence electrons without looking at the atom. So what's the valence of As? What's the valence?
5.
What?
5.
5. When are we expecting to see the highest ionization energy?
After 5.
Which is what?
6.
Exactly, after 5. See? So the valence is already here, and you can tell, again, let's do something else. Let's do bromine. What's the valence of bromine?
7.
7. When are we going to expect the highest ionization energy?
8.
8 ionization energy. I hope this is also clear.
What
No.
about 9, or we can't have more than?
No, you cannot have more than 8.
Yes.
9. I mean, after the noble gases, it will be 9. Good. Next. Next, we just define ionization energy, right? What's ionization energy? For example,
The minimum energy to require to take electron from that.
But it should be what state?
Gas.
Gas.
In gas.
Gaseous state. It must be gas. Okay, this is what would you call this energy? Delta H is called what?
Change in enthalpy.
This is enthalpy, which is this called?
IE.
IE. And it's always positive. Clear? Why is it positive?
Closing electron.
Because you need to put energy to take the electron away. It's not easy to take the electron. Try to break anything. Try to break, for example, something. For example, if something is attached to something else, like if you want to take, if you have two magnets, okay, how can you separate these two magnets from each other? You need to put force, right?
Yes.
Okay, that is ionization energy. Now, we call the other energy, now if you take chlorine gas also, chlorine atom, not Cl2, chlorine atom gas, and add electrode to it to make chlorine ion gas, we call this energy electron affinity. I want you to memorize the names. This is called ionization energy, and this is called electron affinity. Electron affinity. What's affinity means? What's the meaning of affinity? Yes, English. كلمة إنجليزية هذه.
Releasing.
No, affinity means like. Affinity means يحب شيء. I have
close.
No, I have affinity to ice cream. I can say this in English. This is a correct sentence. If you say, I have affinity to ice cream, what does that mean?
Attract يعني.
Attractive me.
Attraction to ice cream. You like ice cream. Clear? All right. But this is called electron affinity. Tell me what's the meaning of electron affinity?
Adding electron.
Like to add electron. Like to add electron. All right? Like to add electron, like this reaction. And what's the value? Look at the value. It's 349. What's the unit for the value?
Negative.
Negative. Negative. All right? If I have this reaction here, sodium plus gas goes plus electron goes to sodium gas. What do you call this reaction?
Electron affinity.
Electron affinity to what? To sodium ion. To sodium ion. If this one was, if the value of this one is plus X, what will be the value for this reaction? What's the
Minus X.
reaction? What?
Minus X.
it will be minus X. So for electron affinity of the ion, not from the whole atom, but for the ion, it is the reverse of the unit like this. Is this clear? Okay.
Doctor, so if I want
Yes.
to, I should take power or
إيش؟
energy.
Again, what again?
يعني إذا بعطي النواة إلكترون لازم آخذ منها طاقة.
إذا بتعطي الأيون إلكترون إيش؟
لازم يعني إذا بعطي ذرة إلكترون لازم أقلل الطاقة الحركية لها أو الحرارية.
إذا بتاخذ, if you want to take electron from the atom, this is always positive. Always. If you want to add electron to ion, then this is always negative because it's the reverse of this one. But if you wanted to add electron to atom, it could be negative, but it could be also positive. You don't know. Is this clear?
Okay.
Okay,
Yes.
good. Next, we call this reaction, we call it delta H, and we also call it electron affinity. No, sir, not electronization. For this reaction, delta H for this reaction is also called electron affinity, but with a negative sign. So let me ask you a simple question. What's the electron, what's delta H for Cl gas goes plus electron to go to Cl minus? What's delta H?
Negative 349.
Good. What's the electron affinity for chlorine gas to take electron to go to Cl minus?
Positive 349.
Exactly. Positive 349. Is this clear? By agreement.
No.
Repeat.
Why it's positive?
That's by agreement by scientists. Okay, is this clear? So yes, the electron affinity was calculated for so many elements, and here you cannot see any trend, but this is now, don't forget, this is delta, this is electron affinity for elements. And that's why if I want delta H for example, for oxygen, delta H for oxygen goes to oxygen gas plus electron goes to O minus gas. What's the electron affinity? What's delta H?
Minus 141.
Minus 141, exactly. Is this clear? Is this clear?
Yes.
And here, as you said, as I said here, the results that you have here is the electron affinity for so many elements, and there is no trend here. You can see it is not easy. But what's the electron affinity for nitrogen? Nitrogen gas plus electron goes to nitrogen gas minus. What's delta H?
minus 52.9.
Nitrogen
Minus 7.
plus 7 plus 7. It is minus 7, the electron affinity. Delta H is plus 7. Is this clear?
Yes.
Good.
Why, Doctor, it's plus?
By agreement, delta H is minus electron affinity. Okay,
Oh, I see. Yeah.
keep this in mind. Delta H is minus electron affinity, minus electron affinity. And what's given to you here is what? Electron affinity. And so what's delta H for anything in here? Equal to what?
Negative, this one.
I hope so. Good. There is no trend, so I'm going to go over this. Now again, look at this number. Look at the number here. Why you think nitrogen is negative? Look at all these numbers. They're positive, 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 positive. And this one is negative. Nitrogen. Why? This means nitrogen, to add electron to nitrogen is not favored. Of course, we know that if delta H is minus, this means it's exothermic and it will happen by itself. But when it is positive, this means it doesn't want to happen. Why do you think nitrogen is minus electron affinity and delta H is positive? Because nitrogen has 3 rooms and when you want to add electron to it, where are you going to put the electron?
With the opposite spin.
Downward.
Add electron 1, 2, 3, and you're going to put one more here. Is this favored?
No.
It doesn't want to do. So that's why it gives -7. Why is this not favored? Why do what?
In each room it's like to have only one electron.
Because what?
Repelled.
Exactly. Electron. What? Repulsion. معناتها طرد. ثاني. Is good. Right. Also, let's look at electron affinity for. Let's look for lithium and Be. See, this one is positive. For lithium, it is positive, and for Be is almost 0, less than or equal to 0, almost 0. Why you think lithium is also does not want to have the other electron? What's the electronic structure of lithium?
One S1.
One S. Okay. What's the electronic structure for lithium minus? And there will be what?
Repulsion.
Not 1s. This is 2s, by the way. 2s, because 1 is below. I care about only the valence electron. Okay. Lithium was 2s1. When we make lithium minus, it becomes 2s2, and we put 2 electrons. What will happen to these 2 electrons?
Repulsion.
That's very strong repulsion, and that's why delta H is sorry. Actually, no, because no, sorry, I made a mistake.
It has only one electron.
Yes. Just a second. I will talk about this in a different way. Okay. Yes. Okay. Lithium has 3 protons, and it's the structure 1s, 2s1, 2s1. Okay, and the 2s is close to lithium. When you add lithium minus, when we go lithium minus, this means we add 1 more electron. Again, we have 1s1 as is, but you put another electron here. And because lithium, the 2s is very close to lithium, the lithium is able to attract the other electron. Lithium is attracting this electron to an extent that it becomes positive. This means delta H is negative, which is acceptable.
Doctor,
Yes.
so the attraction power from the nucleus is greater than repulsion electron, right?
Fantastic. Yes, exactly. That's the meaning. This means the attraction by the nucleus for this element is stronger than the repulsion between the electrons. And that's why this becomes negative. All right. While when we go to BE, I'll put BE here. We have BE, we have B, we have 1s2, 2s2, 2s2. And so this one is full. When you go to B minus, this means 1s2, and then 2s2 also full. This is full, and this is, to start with, this is full. And then when we are full with 2s2, what comes after 2s2?
2p.
2p. And it was empty. It was here empty. When you make it B minus, what's happening? Where are you going to put the electron?
1 1
Right? Right? When you put this electron, the P, the 2p, is further away from the nucleus, from B, and that's, it is not favored. Almost zero. Yani it's okay, but it's not favored. Is this clear? Why? Because 2p is very far from the BE, from B minus, or from the B atom. Is this clear? I hope so.
Yeah.
For each of the element to get, which one would you expect to be greater electron affinity? Aluminum or silicon? Aluminum, and then after aluminum comes silicon. Which one will have greater electron affinity? Aluminum has, you have how many protons do you have? What's the Z of aluminum? What's the Z?
Greater electron affinity is aluminum.
This is 13 and this is 14. Look at your periodic table. What's 13, what's 14? Atomic number, right? Am I correct?
Yes.
Yeah. What's that electron? What's the atomic number of aluminum?
13. Yes, 13 and 14.
14.
Yes.
Right? And it is actually 1s2, and then 2s2, and then 2p1. That's aluminum. How about silicon? All right, silicon here. 14. 1s2, of course. And 2s2 is 2s2 with 2 electrons, and then 2p with 2 electrons, 1 and 2. Okay. Now, which is easier to add electron here to make aluminum aluminum minus, and when we add it, aluminum minus will be 1, 2. Or add it to silicon. When we add it, it will be 1, 2, and 3. This is silicon minus and this is aluminum minus.
I
Which
think aluminum.
is easier?
They are the same.
Aluminum.
No, silicon will be better, because we are adding electron in the same orbital, which is 2p, all right? And then, not only that, the protons is more here than here. Clear? So, which one will have electron affinity better, aluminum or silicon?
Silicon.
Silicon will be more, exactly. Look at the numbers here. Look at silicon. Which one is bigger?
Silicon.
Silicon.
Now, let's go to the other one. The other question now. I want to define the silicon or phosphorus. And then I'll take this away. I want to compare now silicon and phosphorus. This is phosphorus. Phosphorus, what's the number? 15.
15.
To start 1, 2, 3, and then goes to silicon, phosphorus 15 minus. So we will add, it was 3. We want to add electron, we will add it here. Which one you think better, for silicon or for phosphorus?
Silicon.
Silicon.
Why?
Because the repulsion.
Because of electron repulsion now. See, beginning, bigger nucleus, it should attract more, but there will be electron repulsion, and that's why this will decrease. So you can see here, which one is higher, aluminum or silicon? Silicon is higher. But when you go from silicon to phosphorus, silicon is still higher than phosphorus. I hope this is clear. This is because now we have in the periodic table the metals, and you should read the metal characteristic. Okay, and then we have the metalloids, and we have non-metals. You should read the properties. Right? When you go to this, you will find that now let's go to another subject, which is electron configuration of ions. Electron configuration of ions. What do I mean by that? What is the electronic structure of sodium? What's the electronic structure of sodium? Quickly, which is 11. What? 1s.
2. 2s2.
2.
2p6. 3s1.
3s1. Exactly. Exactly. Okay. What's the electronic structure for sodium ion?
PS2 last one.
PS2.
1 is 2. 2 is 2. 2p. What? 6. Good. How about 3 is 1? I'll take it away. Clear?
Yes.
Good. I can make this short by saying it is actually argon. Oh, sorry, neon. Neon 1s. Right? Now when it's become Na plus, what is it?
Neon, exactly.
Exactly neon. Okay. I want you to write the structure of neon. Right? Clear? I want you to write the structure of fluorine minus, which has 9 electrons. Tell me what's the structure? 9 protons. What is it?
Neon.
argon.
1s2, 2s2,
2p.
2p, 2p5.
No, let's do it one step at a time. Write the electronic structure for Fe, F only, which is 9.
2p5.
2p5. Exactly. All right. How about F minus?
2b6.
It will be what?
2b6.
6. Or can you
Yeah.
make it short?
Any.
Simply like an E. This one and this one and neon, which is 1s2, 2s2, 2p6. I have all of them have the same what? They have the same what?
Electronic.
Same electronic what?
configuration.
Structure,
Structure.
right? We call these ISO, write the word here. ISO, what's the meaning of ISO? What's the meaning of ISO?
Same.
English. Same. ISO means same. When I say ISO means same. Isoelectronic. What do I mean by isoelectronic?
Having the same electronic structure.
Okay. Write the configuration for the following quickly. For nitrogen, what is it? Nitrogen N3 minus. Don't forget, nitrogen has
7.
7. Yes, nitrogen is 7. So what's the electronic structure for nitrogen? 3 minus.
Ne.
1s2.
It's Ne. Okay. Clear? Okay, very good. Because nitrogen 1s2, 2s2, 2p3. That's nitrogen. And if you add 3 electrons to it, it will be
2b6.
2p6. Nitrogen 3 minus, 1s2, 2s2, 2p6, which is similar to neon. What's the electronic structure for Ba2 plus?
Rn.
2A2 plus. Go to the periodic table and find the noble gas that if you lose 2 electrons, you will go to the noble gas.
He. Helium.
What is it?
Helium.
It's the structure of xenon.
Xe.
Exactly. What's the structure of Be2 plus?
Helium.
Yes. Exactly. This is helium and this is Be, and nitrogen is Ne. So you know how to write the electronic structure. Good. Now, what will happen to the radius? What will happen to the radius? If we have sodium, this is the electronic structure for sodium. 1s2, this is 1s2, 2s2, 2p1. If you take the electron from sodium, what will happen to the size? What will happen to the size?
Decrease.
Decrease.
Apparently decrease, because you took a whole circle. So the blue circle is gone. There is no more blue circle because it's gone. Clear? So what happened to the size?
Decrease.
Become smaller.
Which is bigger, X or X plus?
X.
Which is bigger in size?
X.
X. Bigger in size, X plus or X2 plus?
X plus.
X plus.
Always, as you go across, the size decrease. Size decrease. Okay, when you have iron, what will happen if you make Cl goes to Cl minus, or fluorine? Fluorine, this is fluorine F, which has 9 electron. This is plus 9. You have outside, what's the valence of electrons outside? What's the valence of fluorine? 7. So how many electrons is the valence electron? 1, 2, 3, 4, 5, 6, and 7. This is the valence electron. And 2 in the core electrons, right? 1, 2.
Yeah.
Right? When you
Yes.
make minus, what will happen?
There will be 8.
There will be 2 inside in the core electrons and 8 the outside. What will happen to the size?
Increase.
It will increase. Tell me why it will increase. The number of electrons become 8. What will happen to the electrons with each other?
Repel each other.
And because they repel each other, what will happen to the size?
Increase.
Increase. Increase. All right. Look at these 3 atoms: neon, F minus, and O2 minus. What is the property of these? These are isoelectronic. Why are they isoelectronic?
The same electronic structure.
The same electronic structure. What's the structure of oxygen? We remember oxygen 1 is 2 is 2, 2p4. All right. And if you make it O2 minus, what will be the structure?
2b6, which would be Ne.
Na.
Exactly. What's the structure of F? 1 is 2, 2 is 2, 2p5. All right. What's the electronic structure for F minus? It will be neon. And neon is 1 is 2, 2 is 2, 2p6. Exactly. Okay. How many protons do we have in oxygen? How many protons?
8.
How many protons in fluorine?
7.
Fluorine.
9.
9.
9.
And neon.
10.
10.
And look at the periodic table. It's available in the periodic table. These are the numbers available in the periodic table. All right. Now I will make this, all of them. This is O minus, F minus, and this is 6 and 6, and they have the same structure. Is this clear? Now, which one of these 3 atoms, or 3 ions, actually, ions and 1 atom, which one is the biggest and which one is the smallest?
The oxygen is
O2.
the biggest.
Why oxygen is the biggest?
Because we add 2 more electrons.
Because there are, look at how many electrons do you have in O2 minus? How many electrons? How many electrons?
9.
O2 minus 10. How many
10.
electrons in F minus?
10.
10.
10. How many in neon?
10.
10.
10. Clear? They're all 10,
Yes.
10, 10. But this is attracted by 8 protons. This is attracted by 9 protons. This is attracted by 10 protons. Which one will be attracted more, in neon or in oxygen?
Neon.
Yeah.
If they are attracted more, which one is smaller in size?
Neon.
Is this clear?
Yes.
This is look at this table here. This show you this one is the size of the atom, and this is the size of the lithium ion. Lithium ion. And this, the blue one. And this one is lithium atom. And what happened if you go from, oh sorry, in the contrary. The blue is lithium. The blue is lithium and the gray is lithium plus. What happened if you go from blue to gray? Always what?
Decrease.
And this one here, the red is the phosphorus atom, and the gray here is phosphorus 3 minus. What happened if you go from red to gray?
Increase.
Increase, because the size increase. Now, let's solve this problem very quickly. Look at these atoms, and I will take in particular argon, and I will take with it phosphorus. Go to your periodic table. I want you to go to your periodic table. What comes after phosphorus?
Silicon.
And then
Chlor.
chlor. Okay. Let's see. And what comes after argon? K.
Potassium.
Potassium. All right. Good. If we have phosphorus 3 minus, how many electrons do you have in phosphorus?
Argon.
How many total electrons?
18.
18.
First, what's the number here? This is, of course, don't forget that this is
15.
9, 18, 17, 16, and 15. Exactly. What's the number of electrons in phosphorus 3 minus?
18.
How about sulfur 2
18.
and
18.
chlorine minus?
18.
And argon by itself?
18.
How about K plus?
18.
Also 18. What do you call these ions and atoms?
ISO.
Isoelectronic.
Electronic. Now, which one is the biggest in size?
Phosphorus.
Yes, that's the biggest. 3 minus, bigger than is 2 minus. And then next,
Because the chlor.
Bigger than chlorine, bigger than argon.
which
Bigger
one is
than
the
potassium.
small?
Potassium.
Potassium.
Or an E.
No, I'm talking about this group only. I'm talking about this group that I made to you now. Is this clear?
Yes.
Isoelectronic. I did not talk about the other elements. All right. So these are having this order. Now, neon, of course, is smaller than argon. Why is that? Because it's above it. All right. I hope so.
Yeah.
And this is actually the electronic structure. Now, 7.7 is not required in this course. So not only this semester, every time we always, sorry. Okay, so 7.7, if you go to your syllabus, you'll find that 7.7 is not required. Is this clear? خلاص يا شباب?
Yes.
And this way we finish chapter 7, and inshallah next Saturday we're going to have a quiz in chapter 7. Okay, and before we, as usual, before we leave,
Doctor,
yes,
on Saturday we have to Mr.
Yes.
خلاص خليه الخميس إذن إن شاء الله يوم الخميس الساعة 9:30.
Okay.
All right. Okay. I want you now.
ما في ميعاد غير الخميس يا دكتور.
Let's do the attendance first. Go to attendance now. I'll open the attendance and